morning, ladies and gentlemen, and welcome to the Theiss, The Future of series. My name is Andrea Gritsch, and I have the pleasure of moderating this event. Throughout the Future of series, we are looking at a wide variety of disruptive technologies and innovation in different industry sectors. Together with leading experts in the areas of business, law, and technology, we explore current developments and future trends shaping the markets of tomorrow and influencing modern society. The future of mobility is on today's agenda, hosted by my partner Sebastian Oberzaucher and our colleague Philipp Mabo.
Ladies and gentlemen, welcome everyone also from my side. Today's presentations reflect the effects of social, economic and technological changes on many areas of law and business, not just the mobility sector itself. These drivers include, firstly, a heightened focus on autonomous vehicles and future technologies. Secondly, new business models affected by legislation, such as the Austrian Single Category Law. Thirdly, e-vehicles and the emergence of services, such as mobility as a service. What is remarkable, though, is how these topics are situated in deeper social and economic developments that we experience daily in our professional and private lives. The challenge, of course, is not only to understand these developments, but to be able to implement strategies in our businesses early enough to remain competitive and, more importantly, to thrive, utilizing these shifts as a catalyst for growth, instead of perceiving them as a threat.
Exactly. I hope you enjoy learning more about these exciting topics, and I encourage you to share your thoughts and questions with the presenters. Now, before we jump right into today's session, there are 3 housekeeping rules to remember. Each speaker is asked to limit his or her speech to 5 minutes. We will display a virtual timeline counting backwards and indicating when the time is up. I would also ask all participants to hold their questions until our Q&A session at the end of the webinar. You are, of course, invited to submit your questions via our chat function at any time. And last but not least, please stay muted when you're not speaking. Our first speaker of today is Stefan Perna, head of the Institute of Civil and Civil Procedures Law at the Vienna University of Economics and Business. Stefan will be looking into the question whether there is unlimited liability for autonomous vehicles. Stefan holds a professorship for civil and company law at the Vienna University. Prior to that, he was professor at the universities of Klagenfurt and Linz. He specializes in civil, banking, and insurance law. Stefan, the stage is yours.
Andrea and Philipp, thank you for your kind introduction, and good morning, everybody. 5 minutes are short, and I would therefore like to start straightforwardly. If we think of traffic accidents, one headline probably comes to our minds. Most accidents happen because of human failure. Drunk driving, driving at excessively high speed provide good examples. This statement has been true for centuries. With autonomous vehicles, the picture is somehow changing. The overall number of accidents will surely decrease, but if accidents happen, they will most likely be caused by technical and not by human failure anymore. It is therefore only fair enough to think about liability in such cases. The question is very simple. Do we need new legislation on the topic? The answer, however, is also surprisingly simple, at least from an Austrian point of view. The answer is no. A short case may serve as a proof of the statement. Imagine, for example, that the owner and driver of a car neglects a red traffic light, therefore causes an accident and injures a pedestrian. Who is liable? Well, the car owner is liable and has to pay damages to the injured pedestrian. If the same accident happens today, not because of the driver's negligence, but because the brakes of the car do not work properly, the owner is again liable. This is because the legal framework, as you surely know in Austria, provides for risk-based liability of the keeper of a vehicle that caused an accident. This is the owner, the leaseholder, or any other person who bears the costs of the vehicle. So if the keeper is liable for a technical failure today, the same must be true in a case of a software failure of an autonomous vehicle tomorrow. The answer is so simple because of the risk-based system of liability that I have just mentioned before. The technical revolution will not be followed by a legal one, at least not in tort law. We can cope with almost, in 5 minutes, we have to cut it short a little, but almost all the problems by simply applying existing laws. And similar provisions apply in connection with accidents that involve trains, for example, or airplanes. Therefore, the situation is the same for these transport mediums, for almost all transport mediums. This is the legal framework in Austria. However, everything is somewhat different across the border. In some countries, there is no risk-based liability of the keeper in cases of traffic accidents. England has been an example for a very long time. In Belgium and Spain, such risk-based liability is restricted to personal harm, whereas property damage is not compensated in a case of a traffic accident. In Finland, the Netherlands, and in Poland, risk-based liability only applies when the claimant is a non-motorized participant. Our pedestrian would be an example, but not another another person involved in the accident if he was a motorized participant. Therefore, it does not come as a surprise that scholars in other countries, and not so much in Austria, have voiced the need for a legal revolution. However, even if we do not have to overthrow existing tort law, certainly some aspects in connection with liability are going to change. Given that most accidents will be caused by software failure, the focus obviously shifts to product liability of the manufacturer of the car and the software. This is going to have an impact on insurance premiums. Premiums in motor liability insurance will substantially decrease, while premiums in product liability insurance are going to rise dramatically, as some scholars predict. After all, at least in one branch of the law, we are expecting some kind of revolution. Thank you for your attention.
Thank you, Stefan. So I gather we are safe in Austria as it regards the legal framework. That's good to know. Our next speaker is Martin Essler, head of Uber Austria, addressing the effects of the new single category law on the Austrian mobility market. Martin is managing director and representative of Uber in Austria. Prior to his Uber engagement, he spent many years in the telecommunications sector, including at Siemens, Sony Ericsson, and Twitter, and lived in China, Taiwan, and the USA. After moving back to Austria, his main goal now at Uber is to find ways how technology can improve mobility, sustainability, and quality of life in cities. Martin, we are very happy to have you here today.
Thank you very much for having me, and thank you for the introduction as well. 5 minutes is short, as we said, so I'll dive also right into maybe a quick history of Uber in Austria before we get started. We started our business here in 2014 in partnership with many PHP companies. And up until the end of 2020, we were operating together with these PHP partners. Starting in 2021, we had to transition over and partner with taxi companies. Now, what are we actually talking about when we talk about a single category law? It's a very generic term. We're talking about the Occasional Transport Act. And this Transport Act regulates non-public passenger transportation, which is a regulated trade in Austria. Among school transport, medical transport, it also in the past regulated PHV and taxi businesses. In July 2019, during the intermediary government, the parliament passed a law that combined taxi and PHV into one category. Now, before PHV was a pre-booked trip, the price was known, the route was known, and PHV category was introduced when no mobile phones existed, right? When you couldn't just call the driver where to go. While taxi, so PHV was for business travelers calling a company saying, I need a car to pick me up at the airport and bring me to a hotel, or pick me up at a train station or hotels. hotel transportation. Taxi was street hail. So taxi drivers needed to know the city by heart. They needed to know traffic conditions. They needed to know the roads by heart, etc. And they had a taxi radio in the past, in the 60s in the car. When Uber came, PHV became digitized. So it was quite easy with an application to tell a business owner, hey, we need a car here. And this happened in a matter of seconds only. So there was a need to reform this law in Austria. The businesses were combined. But the problem is the combination that happened, that was decided in 2019, was that mostly the taxi rules were applied in the new law, completely eliminating the PHV business. So all of a sudden, thousands of drivers couldn't drive anymore because they needed a taxi driver's license. Pricing was regulated with a taxometer. So all the technology advantages that a company like Uber introduced were vaporizing with January 2020. This was heavily criticized by the Federal Competition Authority. And last minute, in December 2020, there was a change made to this law, allowing for pre-booked trips to be excluded from the taxometer. What this means is that when you street hail, you can get a taxometer trip, you get in the car, the taxometer tells you how far it goes. That's good for consumer protection. The taxometer tells you the price for the trip. That's good for consumer protection. When you pre-book a trip, you can see the price up front, and you don't need a taxometer to tell you the price. So you already have certainty as a consumer. But still, there were two main problems with the single category, even after the changes in December 2020. One was that drivers needed a taxi driver's license. This means half of the supply in the market of drivers disappeared. And the effects of that are now visible in the city of Vienna, where we have lack of drivers on the roads now that the corona lockdowns are gradually over. And the second one is there's a pricing regulation. So taxometers have a taxi tariff, but also pre-booked trips need to follow a certain pricing regulation, especially in Vienna, where there's a price band up and down. And this pricing regulation does not maximize, in an already tight marketplace, the opportunities for businesses and the reliability for riders. So the effects at the end of the day of the single category law is increased prices for consumers, lack of supply leading to lower quality because of unreliability in the market, and unavailability with no drivers and no taxis on taxi stands, no drivers available on online platforms like Uber. The price band does not allow for self-regulation, meaning the prices can't go up into a certain level, making it more attractive for businesses to go online, but also they don't go down further a certain level because of the Viennese regulation, not allowing for more riders to enjoy personal mobility with taxi. There's an impact on safety because of this unreliability. Late night trips home difficult to get, especially at weekends. Young crowds cannot rely anymore on getting a safe ride home at 2 a.m., needing to walk longer distances or find alternatives. There's an impact on tourism, business, and casual. And there's an impact on sustainability because people go back to their personal cars. They can start leasing cars again. So what we need to improve is we need to make it easier to become taxi drivers, make sure we get supply back fast, that supply that was lost with the single category law, and we need to deregulate the pricing. And that can happen on a state level or that can happen on federal level as well. Thank you.
Thank you, Martin, for this insight. This was really interesting. We move to a quite different topic now with Anna Freund, Associate at Theiss Vienna, checking the question whether shooting of a drone is admissible as a right to defend one's own interests. Anna is a member of Theiss dispute resolution team after having spent several years in a London-based law firm in international litigation and arbitration. Anna is a qualified solicitor in England and Wales and in the Republic of Ireland. She is also a member of the London Court of International Arbitration and the Young Austrian Arbitration Practitioners. Anna, the stage is yours.
Good morning, everyone. So I would like to start my talk with the following scenario. Imagine you have a beautiful garden. Imagine you sit in your beautiful garden and the sky is blue, the sun is shining and all you hear is the sound of birds and it's absolutely idyllic. And then suddenly there's a drone. Let me just get my drone background. I can choose this. There's the drone. What can you do? Can you knock it down? Practically, of course, there are loads of options, but that is not the topic of my talk. I'm here to talk to you about whether it's lawful to shoot the drone and to protect your own interests. So first off, to say, in Austria, the legal situation actually hasn't yet been clarified. But if the owner of the shot drone complains, there are 3 grounds under which you could argue that you have legally taken the drone down. The first one is self-defense, which we call Notwehr, and which is contained in Section 3 of the Austrian Criminal Code. For self-defense, the person must be in a situation which merits self-defense. There must be an unlawful, imminent attack on one of the rights contained in the exhaustive list in Section 3. These are life, health, physical integrity, sexual integrity, freedom, or property assets, so the German word is Vermögen. Interestingly, and problematically for the purpose of our analysis, is that attacks on privacy and the person's sphere are not included in that exhaustive list. That means you couldn't argue self-defense if you merely thought your privacy was invaded, but of course that's precisely what most people think of when we imagine a drone flying over the property. But to argue self-defense, there must be something more than that, so you must find a reason listed in Section 3. So looking at Section 3, you could argue that a drone infringes your property asset rights. According to Section 297 of the Civil Code, the right of ownership also of your property also refers to the airspace vertically above your house or your apartment or garden. However, the use of airspace is free for an aircraft pursuant to Section 2 of the Aviation Act. Some drones fall into this section and some drones don't. So, for example, if they're too light, they're considered toys, so they don't fall into the section. But for the drones that do fall into the section, those drones are legally allowed to fly over your private house or garden, so that would not be an unlawful attack. So property owner would have to tolerate that. However, if the drone starts circling above your property, particularly if it's relatively close to the ground and for a longer period of time, that could be seen as an attack. Now imagine you're naked in your garden and a drone is circling above your property, seemingly taking pictures or filming you. Can you argue self-defense based on invasion of your sexual integrity? That's actually not clear. There's no clear view on this. Some say that you should be able to argue that. Some say that you shouldn't because it doesn't fall into self-defense because there is an actual attack. If you can't make it self-defense, there's still necessity, which we call Notstand. The justification of necessity can be invoked if there's an imminent threat of significant harm to an individual right, and that includes privacy and the personal sphere. So if the filming or photographing drone poses a threat of immediate significant harm to your privacy, you can bring down the drone and you can damage and destroy it if that's the only way to restore your privacy. So it's not possible to find the drone operator and ask him to remove the drone, which practically will be the case because it's very difficult to communicate with the drone. But if you do this, you must pay attention to third parties and the property. Just imagine a drone crashing on someone's head. And also to note is that there is the requirement that the individual rights saved must be of higher value than the one sacrificed. But that will be fine because your personal right to privacy will be regarded, and it's higher than the right to property of the drone. Thirdly, there's self-help, which we call Selbsthilfe, and that's contained in sections 19 and 344 of the Civil Code. These provisions stipulate a person's right to defend his or her rights in an appropriate manner if state help, so that would be the police or the court, would come too late. Self-help is not limited to the defense of specific individual rights, but it's focused on the enforcement of civil law claims in general. So, for example, when it comes to interference with possession, so Besitzstörung, or violation of personal rights. The goal here is to restore the lawful condition. With regard to drones, the danger posed by the drone must be averted with appropriate means. So that will depend on the value of the aircraft, the type and duration of the impairment caused, and the method used to remove the drone. So like a lot of things in law, it's a balancing exercise. And interestingly, this is the approach a German court took last year. So they found the father shot down a drone which circulated above his garden, and that was justified on the basis of self-help. I can see I'm really close, my time is almost up, just one last sentence. Even if you're not liable for prosecution for shooting down a drone, you may be liable for compensation under civil law, but contributory negligence on behalf of drone owner would apply.
Thank you very much, Anna. You've led the path directly towards our next speaker, Valerie Hackel, Managing Director of Austria Control, on the topic of new European drone regulations and whether it is indeed a risk-based approach enabling future technologies. At Austria Control, Austria's air navigation service provider, Valerie is responsible for safety in Austrian airspace. Beyond air traffic management, Austria Control spectrum includes engineering and meteorological services, airworthiness and certification, search and rescue operations, as well as pilot licensing and the authorization of drones. Prior to her current position, Valerie was a member of the executive board at ÖBB, Austria's largest mobility services provider, where she launched the NightJet service, Europe's largest night train network. Valerie holds a business management degree from the Vienna University and a doctoral degree from the University of St. Gallen. Valerie, we're happy to have you here today.
Thank you. Good morning from my side. Yeah, as we've already heard, the entire drone sector has experienced an incredible dynamic development in the recent years with intensive research and innovative applications being tested. If you look at studies, those predict that drones will develop into a multiple billion-dollar industry. And for us, it's especially thrilling as we've approved, for example, a test flight for the Red Cross a couple of weeks ago, where a drone delivered a blood supply to a hospital. So this phenomenon is not theoretical anymore. It's actually already reality. However, and this is especially the role of Austria Control, we are highly interested in the safety in the air and on the ground, and we need to make sure that suitable framework conditions are in place. So what is needed, therefore, is a regulatory framework that promotes and enables these innovations while at the same time ensuring that these devices are safe to use and do not endanger anyone. So this new EU regulatory framework has been in effect since December 31, 2020. Until recently, so before that, the use of drones was regulated nationally by each EU member state individually. So now with this new EU drone regulation, flying with drones in the EU is now harmonized with simplifications for drone users, but also for manufacturers. And the good thing is that you can, as a drone user, apply the same regulatory framework and have the same rules in place no matter where you are in Europe. What is very nice for Austria Control is that this new regulatory framework was developed in line with the national regulatory framework that we had in place in Austria, namely with a risk-based approach. What does it mean? It means that with an increasing risk and with increasing complexity, the rules change so that the use of the drone at any time is safe. So the requirements are therefore based on the weight of the drone and area of use. The principle is that the higher the risk of the drone operations, the more demanding the requirements and conditions become, and that's where we get involved. To give you an idea, there are 3 different categories in place. One is called open, it's the one with the lowest risk profile. Specific is a bit more sophisticated, and then certified, third category, that can be compared to manned aircraft. So let me take you a quick tour around in these 3 categories. Now, the open category amounts for the most use cases, approximately 80% of the use cases apply to this category. And if you have a drone yourself at home, or maybe a relative of yours, you might most likely fall into this category. Here we speak of drones under 25 kilogram who do not need an official operational authorization anymore. You only need to register the drone as a drone operator, that is mandatory, and you need to acquire a so-called drone license as a pilot of that drone. So this is much simpler than it used to be before. It's also less expensive than before. So this is really, I think, much easier now to apply. However, you must not exceed a maximum flight level of 120 meters. And depending on the weight of the drone, a safe distance to uninvolved persons has to be maintained at any time. And you're only allowed to fly the drone in visual line of sight. So you at all times must be in sight contact with the drone. This is the category open, as I said, that amounts for the most cases that we know for the time being. A bit more complex is the second category that is called specific. Here you have wider areas of use, and it allows drone operations beyond the visual line of sight, especially, for example, for surveillance of infrastructure necessary or for other more complex cases. And you're allowed to fly drones with more than 25 kilograms. You can fly above 120 meters above air. And in urban areas, you have less restrictions. Now, this specific category involves that you need to undertake a risk assessment as the drone operator or the drone pilot. And this risk assessment must be approved by Austrocontrol. And we're happy to support our operators and pilots along the way because the whole subject is relatively new. And we see that it's best to develop those risk scenarios and assessments jointly. Now, the third category is the certified category. It caters for the operation with the highest risk. Therefore, this certification process is really similar to the manned aircraft domain. The precise provisions of this category are currently being developed by EASA, so we still need to wait for the final regulations here, and we expect the publication by the end of 2022. These use cases relate to the transport of passengers, to the transport of dangerous goods, and the like. We are happy that by now, so for the first almost 10 months with this new drone regulation, we've already registered more than 25,000 drone operators, more than 35,000 pilot licenses. So we see that this new regulation is being accepted relatively well by the public. Also, as I said, Austrocontrol understands itself as an enabler for drone operators in general. So we want to be a reliable partner to those who develop new technological solutions and application areas. And we try to assist the industry in the application of the new EU regulation. Just let me give you an example. The first European light UAS operator certificate, it's called LUC, was issued by us to Schiebel, maybe a company that you know, based in Austria. This LUC, this certificate, allows Schiebel in that case, or in general drone operators, to authorize certain drone operation themselves. So this is really a lever to less complexity. This LUC is valid in all EU member states. Here again, it's harmonized, and we can support Austrian companies to perform internationally in the drone segment. So this is a strong signal, we believe, for future international competitiveness for Austrian companies. Another example would be Austrian Power Grid, who conducted their first drone long-haul flight for the inspection of their power lines. This covered more than 100 kilometers and was performed beyond visual line of sight. So here again, we try to assist here in EU use cases. Now, last but not least, let me give you a quick outlook. Drones at the moment are still phenomenon needs to be assessed and monitored very closely by a case-to-case procedure. In the end, we believe that the drone's airspace will merge together with the manned aircraft space, and it will then be called so-called U space, where those two merge together. And for this, we need, of course, sophisticated traffic management systems. That's something we prepare at the moment. We prepare ourselves together with technology partners, so that a new set of services and specific procedures in particular can be designed to support the safe, efficient, and secure access to airspace for all drone operators, but at the same time for the manned aircraft as we know it for the time being. Thank you very much.
Thank you very much, Valerie. It's very interesting to see how these new rules translate into real life. Our next speaker in this area is Harald Traut, co-founder and CEO of Austrian InsurTech Dolphin Technologies. Harald, you have a catchy title, Why Can't I Look at My Mobile Phone While Driving? Harald is specializing in the insurance telematics market. He is a pioneer and thought leader in the vehicles telematics industry and has worked with dozens of insurance companies worldwide. Harald holds a master's degree in organizational development, a dual MBA from the University of Minnesota and the Vienna University of Economics and Business, and he's an alumnus from Stanford University's Theiss School. Harald received the US BITS Award from the Austrian Chambers of Commerce, and his company was also honored by the Austrian state for its market-leading position. Harald, let's hear you out.
Thank you. Good morning, and thank you for having me. So we have been hearing about self-driving cars and drones. I want to talk about the present and not so much about the future. So as we learned, self-driving cars might be years and even decades away. And the question is, how can we survive in the current environment? And this is exactly what we are working on in order to understand how we can help people to avoid road accidents. So as it was mentioned before, about 99-point-something% of accidents happen because of human failure. So we're not aiming for solving technical issues, but we're solving basically behavioral economic issues. Our business model is to helping insurance companies to help drivers driving safer by rewarding them for safe driving behavior. So when you tackle the problem of, let's say, solving car accidents or helping people for not having road accidents in the first place, we first have to understand why road accidents happen. So if you would have asked me about 15 years ago, we would have said it's velocity and it's drinking while driving. This is not true anymore. There are other things that happen that make us have accidents. When we started to investigate about what are the main reasons for road accidents, we found out that about 26% of all accidents occur because a smartphone is involved in some way, because you're talking while you're driving, because you're texting while you're driving, you're looking at messages, or even checking whether somebody likes your Facebook status. Now it's Instagram because Facebook is fading out, but nevertheless, you're looking at your smartphone. Now, today, a couple of years later, we have arrived at 37%. So 37% of all accidents happen because people are using their smartphones while driving, or even using their smartphones while they're walking, crossing a street, or using the smartphone even while biking. And there is a second reason, which you might not be aware of, and I hope this is a
Harald, I think we're losing you. There seems to be a problem with your connection.
Can you hear me now?
Yes, we just lost you for half a minute.
Okay, that was actually the most interesting part. So I'm going to repeat that very quickly. We found out that there's a second reason besides using the smartphone, which is actually short trips. 25% of all accidents happen within the first 3 minutes of driving, and parking damages are not included. So we're talking about real accidents. So today, if you want to avoid accidents for yourself, our recommendation is not using your smartphone while driving. This will occur for about 37% of all accidents. And even though there is an overlap, try to avoid very short trips, because 25% of accidents happen within the first 3 minutes of driving. And interestingly, 40% of all trips last shorter than 10 minutes. So if you can convince yourself, or you're walking, using a bike or public transportation or even an Uber when you have short trips and not using your smartphone while driving, you're much safer off. Thank you.
Thank you so much, Harald. That was very enlightening, I have to say. Our next speaker in line is Nicowitz on tests of autonomous vehicles on public roads, challenges or opportunities. Michael is coordinator for automated mobility at the Austrian Federal Ministry for Climate Action, Environment, Energy, Mobility, Innovation and Technology. He holds a master degree of science in engineering and mechatronics and robotics, as well as laser engineering from the University of Applied Sciences, Technikum Vienna. For several years, he worked in the automotive industry in the field of alternative drivetrains and their energy carriers. Michael has published several papers and books on the successful implementation of hybrid and electric vehicles, automated mobility solutions, as well as scientific textbooks for children. Michael, let's hear you out.
Thank you very much for the kind introduction, and good morning, ladies and gentlemen. It's my pleasure being with you today, and I'm happy to share some thoughts and ideas. Well, automated or even autonomous vehicles are indeed one of the most disruptive technologies in today's world. However, fully autonomous vehicles are still not commercially available today due to technological problems, lack of harmonization and standardization, as well as the underestimation of human beings. Hence, local authorities and governments in special are playing a major role by defining next steps and legal frameworks for a successful and sustainable implementation of automated vehicles. That's the reason why we as ministry started to build up test environments and test beds for automated vehicles years ago. Now it's possible to test there from the very first beginning, from the very first scratch, till the end of the product development, which means you can test their hardware in the loop, software in the loop, simulation, digital twins, virtual testing, and even test and closed tracks. However, it's crucial to test automated vehicles on public roads, especially when it comes to mixed traffic between automated vehicles and non-automated vehicles, so commercial vehicles. And that's the reason why back in 2016, we started to establish the so-called Automated Driving Act. The Automated Driving Act is the kind of legal framework where we defined the conditions and the framework under which it's possible to test automated vehicles on public roads in Austria. And right now, there are 3 applications which you can test on public roads. And this is the automated highway pilots, automated or autonomous shuttles, as well as self-driving military vehicles and machines. Testing companies have to submit a test report afterwards. They have to tell us, they have to show us what was going on, what was working well, and where they had problems. And based on these reports, I can tell you now that there is still a long way to go because of technological problems, because there are a lot of technological hurdles to overcome. Technology isn't working very well in the better wet conditions, for example, fog or during heavy rains. We also know that there is still a low acceptance in public, but also regarding customers, because they're telling us, please stop talking about autonomous driving. I even don't understand the function of my automated lane keep assistance system. We also know that there is a cooperation on a very low level between infrastructure operators as well as car manufacturers regarding the required physical or digital infrastructure. We know that there is a huge amount of data being processed, and we realize that here we're talking about 8 terabytes of data per hour. So we should stop talking about big data and much more about smart data, and so on. And based on these results, we now know that it requires a lot of control and steering measures for a successful and mostly sustainable implementation of such vehicles. But that's the reason why I'm happy to inform you that with the beginning of next year, we will extend the existing regulation framework by adding new applications to the existing ones. And then it's possible to further test automated working machines, automated highway pilots, automated valet parking, as well as automated vehicles for persons, as well as automated vehicles for goods on public roads in Austria. We're doing this because we as public authority need to gain information where we really are. We need to gain information what the technology is capable to deal with. And we need this because it requires steering measures. Because what we know right now is that automated or even autonomous vehicles will not lead automatically to better mobility of the future. Therefore, it needs a strategy and a framework. And with our new framework, I'm quite sure that will enable the next steps towards a safe implementation of the technology. Thank you very much.
Thank you very much, Michael. That was very enlightening. We're moving to our next speaker, Kurt Retter, partner at Theiss, on the topic of am I an electricity company when operating an e-filling station? Kurt heads the firm-wide regulatory team and has specialized experience in the regulated industry, amongst others energy, telecommunication and rail, life sciences and environmental law. Holding degrees from Vienna University Law School and Yale Law School, Kurt started his professional career teaching constitutional and administrative law at the University of Vienna before joining the firm. Kurt, we're looking forward to your speech.
Thanks, Andrea, for the introduction. The interesting question here is whether I am an electricity company when operating an e-filling station. The background to that question is actually that under Austrian law, there had been discussions legally whether the operation of an e-filling station would require a license under the Trade Act, or whether it would be subject to the provisions of the Electricity Market Organization Act. The significance of that question is quite large because while obtaining a license under the Trade Act is a fairly straightforward procedure, also applicable to traditional filling stations, the applicability of the Electricity Market and Organization Act would place a much stricter regulatory regime and regulatory burdens upon the operator, thus substantially hindering the rollout of e-filling stations. So, as I said, the question had been unclear and disputed in legal literature for quite some time, and it was finally clarified by the highest administrative court not too long ago. And the court actually held that the Trade Act obviously is the starting point, where the Trade Act says that it explicitly exempts electricity undertakings from the applicability of the Trade Act. So that would mean that if the e-filling station would be an electricity undertaking under the Electricity Market and Organization Act, then it would not be possible to claim that the e-filling station would fall under the Trade Act, which would be a more lenient, easier regime and which would allow for a better rollout. Basically, the court said that according to the law, to the Electricity Market and Organization Act, the electricity undertaking would be anyone who performs for profit at least one of the functions of generation, transmission, distribution, supply, or purchase of electricity, who also performs commercial, technical, or maintenance tasks related to those functions, and however not including final customers. The point there is, of course, that at a first glance, and this was also the stance taken by the authority of first instance, this would come into the e-filling station would actually come into the remit, the applicability of the Electricity Act. However, the court decided differently, fortunately, and it said the decisive question is whether the operation of the e-filling station falls within any of those functions just mentioned. That is, does the operation of an e-filling station constitute the generation or transmission of electricity? In that respect, the court said, well, the decisive point is that the e-filling station is about the sale of electricity. So it does not matter whether the e-filling station is based on an own generation facility or whatever, or whether it's electricity that the e-filling station also buys and then resells. So it's simply irrelevant because only the sale is decisive. And the e-filling station is not about transmission or generation. However, it had to grapple a little bit without the distribution or supply of electricity, because in a way, of course, the e-filling station would fall within that function. However, the court said there that the mere sale of electricity does not in itself constitute a function giving rise to the operation of an electricity undertaking, especially since suppliers within the meaning of the Electricity Act would have to be active in a network, in an electricity grid, or have customers in a network, in an electricity network, in an electricity grid, which would not be the case for e-filling stations. And finally, it also held that it would be irrelevant that in order to resell electricity, the e-filling station would first have to purchase electricity, since, as already mentioned, the sale would be the decisive action. So, of course, one could have seen it differently, but that was the decision taken by the administrative court. It also held that a further argument could be made that the Trade Act in itself did not consider electricity traders at all, or the mere sale of electricity, to be part of the operation of an electricity undertaking, independently from assessing the definition in the Electricity Act. They based that on the different definitions of the term of trader in the Electricity Market and Organization Act on the one hand, and in the Natural Gas Act on the other. And they held that this, which is the reason why the Trade Act does not contain an explicit exemption for the electricity traders, corresponding to the explicit exemption provided for by natural gas traders. So, summarizing, basically, the Austrian highest administrative court, the Verwaltungsgerichtshof, has provided us with an important legal basis for facilitating the rollout of a broad network of e-filling stations across Austria in a situation where before there had been a lot of uncertainty. So, Andrea, that was all that I could say about this. And I think as your picture pops up, I've been right on spot, I hope. Excellent. And as always, the devil is in the detail when it comes to the legal world. Thank you so much, Kurt. You're welcome. Next in line, we have René Stadler, CEO of Umadum Service, giving us insight into the question, how can we reduce road traffic easily? René holds a master's degree in geography from the University of Innsbruck and has long-standing experience in the energy and mobility industry. As CEO of Alpha Hub and Umadum Service, he uses his network in the mobility sector and expert knowledge in the field of sustainability. René, happy to hear you out.
Yeah, good day from my side. Thank you for the introduction and for having me. I also want to focus on our current situation and on the challenges we as a society are facing. This is traffic on one side, of course, and then the problems it causes on certain or in certain regions and at certain times on the infrastructure. But the biggest challenge we are facing is the climate change, and as actually our traffic system is built up, it has a huge impact on our climate system, and we are working on it, and technology providers from all over the world are working on it, but it needs some big changes happening. And we are focusing more on the people themselves and on the behavior of people, and how we are able to maybe change this in the future. And we say infrastructure for an efficient and climate-friendly traffic system is already here. We have vehicles in different sizes and different categories. Then we have, of course, the possibility to walk and bike. And we say the cars that are here already are the solution for the problem. It's only the rate of occupancy that's a big challenge, and we're trying to increase this rate. As we were talking about, or we are hearing about autonomous driving before, I think people are already up for this, because when looking around in the traffic jam or before red lights, and if you look at people are putting out their mobile phones and checking their time frames or the social profiles. So people are happy not to have a closer look on the road in front of them, and more or less people are willing to hop into a car to just do what they want to do with their mobile phones. So we say people are ready for ride sharing, and ride sharing could be a huge impact, or could have a huge impact on our traffic system, as it enables to increase the rate of occupancy, and this means more people in a car, less cars on the road. So how will this be possible to get people to do so? How will they be catchable to let their car at home and just walk, or share a ride to work? So we are focusing on the network of people and of institutions having an impact on our way we move daily. This is, of course, when we go to work, for example. This is when we go to check our health issues, or if we do it for leisure reasons, and we implement a kind of bonus system and hand this out to partners like municipalities, for example, or companies, and they are able to give out points and reward people if they change their way of moving, change it to a more climate-friendly way of moving, for example. And if this system grows, and if more partners come in and distribute points to move people in a certain way of action, we are able to shift the mobility behavior big time. And this has a huge impact also with the existing infrastructure and with the existing technology we are having today. This is what we do at the moment. So in our perspective, it's not the vehicle itself that enables us getting from A to B at certain times. It's the access to different vehicles, and it's not the ownership that is building up the mobility of the future. It's the access, and also when autonomous cars will pop up in the future, we make people ready now, because from their point of view, it doesn't matter if the car I hop into is run by a company, is run by a private person, or there is no driver in it at all. And this is what we think will make the mobility of the future. It's the combination of different modes, but it's the cooperation of different institutions to more or less get people to change their behavior, as this is the most or the biggest problem at our current situation, facing climate change as the biggest threat we as a society have ever faced. This is it.
Thank you so much, René. I think this caused quite a lot, so thank you very much for enlightening us. With our next speaker, Nicola Weiros, the co-founder and commercial lead at Team Tumbleweed, we're moving out of space, so to say, with the question, is it possible to explore Mars effectively? Nicola is co-founder of Team Tumbleweed, a startup developing technological solutions for deep space applications. The now 80-member team has been working on their flagship project, the Tumbleweed Mars rover, for 4 years. Nicola has a background in physics and management and has previously worked in consulting. Nicola, very interested to hear you out.
Thank you so much for the kind introduction, Drea. I think the fact that we as a species are exploring another planet is quite remarkable. And despite some setbacks, our history of Mars exploration is marked by many, many successes. However, I think this is only the very start of this journey. So to give some context, when we rediscovered America, a few people went there by ship. Now, when we want to go to America, we just board a plane. And I see something very similar in the future of space. Human presence in space will be the norm rather than the exception. And in order to make this next step in space exploration, and specifically Mars exploration, it is necessary to ask this question: is it possible to explore Mars effectively? But before actually discussing this key question, I would like to give some motivation on Mars exploration. Why would we even want to explore Mars in the first place? Apart from sheer curiosity, there are two reasons. First, increasing our scientific understanding. So the scientific value of Mars exploration is quite straightforward. It is just highly interesting to many fields such as geology, astronomy, biology, and many, many more. Furthermore, in studying Mars, we also learn about the future of our own planet, quite sadly. So secondly, the prospect of a space economy and eventually a Mars colony is commercially attractive. we want to one day send humans to Mars and make life interplanetary. And to do so, we of course need to know the place we're going to first. So let's start off with the status quo of Mars exploration. In general, there are two ways of exploring Mars: in orbit and on-surface exploration. We'll start off with in-orbit exploration. So this means orbiters, which are basically satellites in the Martian orbit. And apart from taking beautiful images, they also gather highly interesting data about the Martian weather, the landscape, atmosphere, minerals, and much, much more. Scientists are extremely ingenious with the data generated by orbiters. And orbiters, of course, they orbit the planet, so they collect large-scale data about Mars, which is, of course, a good thing. However, there is one very obvious pitfall. Orbiters are very distant to the objects they measure, and therefore the resolution is suboptimal. So, on-surface exploration methods come to rescue, at least partially. Apart from rovers, there are, of course, other methods such as landers, penetrators, and newly also drones on Mars. I will stick with rovers, just for the example. Rovers are great at taking highly specialized, high-resolution data. And, from an engineering perspective, they're also a piece of art. However, rovers also have certain pitfalls. Rover missions are highly complex, especially the landing maneuver here is an issue where typically this landing is performed with a parachute and a sky crane, and it's just super complex and therefore also prone to failure. And as a result of this complexity, rovers are highly expensive. The fact that rovers so far have been a one-off thing, of course, does not help in curbing the cost as well. And lastly, rovers are extremely slow. As a result, these can almost be regarded as point measurements. So for reference, NASA's Curiosity rover made roughly 20 kilometers in 8 years, which is really not a lot. So in order to explore Mars more effectively, I want to introduce 3 ways to rethink Mars exploration. And just to be clear, these are not, things I made up for this talk, but actually paradigm shifts that happen in the industry right now. So firstly, we need to rethink risk. To set the baseline, the space industry is inherently risk averse. This is quite logical as missions are extremely expensive. It, however, creates some sort of feedback loop. More cost leads to more risk, which then leads to more cost, and you see where I'm going with this. On another note, the cost of sending something to space has decreased strongly and is expected to do so in the future. And there are more and more enabling technologies for space exploration. So as a very popular example, I'm pretty sure most of you have heard of SpaceX and their reusable rockets. And this is, of course, only a piece of the whole story, but it illustrates the fact of this decreasing launch costs super well. Furthermore, there is an ongoing trend in the industry of using less reliable, but also much cheaper components in Earth orbit. And while this, of course, increases chances of critical failure, it quite logically also lowers the cost of such missions even further. So considering all this, there is the need to rethink the inherent trade-off between cost and risk, and also consider low-cost missions in the future. Secondly, we need to rethink the role of different players in the industry. What do I mean with this? Traditionally, only large space agencies have participated in Mars exploration. For this first push to Mars, it was surely necessary that these organizations with very large budgets made the first step. But just like for missions to the Earth orbit and the Moon, an increasing number of private Mars exploration missions is taking place. And here it will be necessary to involve all the established stakeholders and also rethink all of their roles. And third and lastly, we need to rethink our exploration methods. As previously hinted at, all current exploration methods such as orbiters and rovers have different strengths and weaknesses. And as a result, a diverse variety of exploration methods will be needed to explore Mars effectively. Here, for example, the recent use of a drone on Mars is very welcome as it opens doors. This is also actually something we at Team Tumbleweed aim to do, bridging the gap between rovers and orbiters and providing large-scale on-surface data. But this is actually for another talk. Until then, thank you for having me.
Thank you, Nicola. The mind boggles, I have to say. So that was really interesting. Thanks for that. Our next speaker is Philipp Mavo, Council Head of Theiss Vienna. Philipp, you will be speaking about mobility as a service. Philipp is a member of the Wolf Theiss public procurement team with more than 15 years of experience with a particular focus on public procurement, project development and contract law. Philipp advises clients in large-scale infrastructure and PPP projects in Austria and Central and Eastern Europe, in particular in the transport sector. Philipp, this is your stage.
Many thanks, Andrea. My topic today is to explain what is hiding behind the term mobility as a service. And I'd like to proceed with examples. For this, I have to admit that I will come back from Mars to Earth. And my first example would be that most of you have surely experienced to arrive somewhere at an airport wanting to get as quick as possible to the city center. Laudably, you go by public transport, and the first thing you're confronted with are long queues in front of ticket machines. On top of that, when it's finally your turn, a quite tough fight with the machine unfolds. You don't look through the several zones, you don't find the right station, let alone a reduction which you might profit from. Often this fight ends with a ticket that does not really fit. Anyhow, it means a loss of time and it gets on your nerves. Or the following situation, you have small kids move to the suburbs, and when you get off the train in the evening on your way home, there still lags quite a distance. Indeed, there is a bus, but it runs only once in a blue moon, and you needed to buy an extra ticket. At this point, each time you wish to have a bicycle available, or a scooter, an e-scooter, also a shared cab would do. Just something that would spare you and your family to walk home at night time. And another scenario will be familiar. You and your friends have allowed yourselves a culinary weekend. Everybody drove by car to a common dinner. As the time and evening progresses, the convivial atmosphere has led the group to consume more wine and beer than planned. When it's time to leave, everybody tries to get a cab, which proves to be complicated. The next village is far away, the number of available cabs limited at this hour. In this situation, the friends wish they had some vans at their disposal to drive the whole group to its accommodation safely. So here we are, 3 examples, 1 solution, which is mobility as a service, my topic today. So what it is about? It is about a totally new approach to how imagining mobility. It is not the transportation companies and the service providers anymore that take the center stage, but the passenger, the client, the demander for mobility. Around his needs, the new world of traffic and mobility shall be conceived and built. Regardless if tramway, metro, bus, cab, scooter, car sharing or shared cab, all means of mobility are implicated. Mobility as a service addresses both the public and the private sector. As integrated concept, it is enabled through digitalization and the widespread use of smartphones. The aim is to offer the user a single application and a single payment channel instead of multiple ticketing and payment operations. Mobility as a service is still a relatively new concept. Several questions and problems must be solved, also legal ones. At the same time, mobility as a service holds a multitude of possibilities, not only concerning the mobility of tomorrow, but also far-reaching possibilities for new business models. To conclude, I'd like to emphasize a particular impact of mobility as a service. Due to its more efficient use of transportation means, it supports a reduction of travel by car. This benefits the environment, the climate protection, and sustainability. Therefore, mobility as a service benefits all of us. Many thanks for your attention.
Thank you, Philipp. And I think the last note is something we all cheer to. Thanks again to you. Our last speaker of today is Tim Rüdigam, postgraduate and research associate at the Technical University of Munich. And Tim is looking at the question of safety of autonomous driving. Tim is currently a visiting researcher at the University of California, Berkeley. His research focuses on safe and efficient motion planning for automated vehicles in challenging environments. His research results are regularly published in scientific journals and presented at international conferences. Due to the time difference in the US, Tim could not join live today, but recorded his pitch. And here it is.
We've been promised automated vehicles for a while now, but the reality today is we still need to drive ourselves. Why is that? In the end, it all comes down to safety. My name is Tim Brüdigam. I'm a PhD student working on automated driving. In the next 5 minutes, I'll give a brief introduction to safety considerations for automated vehicles. How safe is automated driving today? This question is not actually easy to answer, especially because 100% safety does not exist. Let me pose a simple question. Consider an autonomous vehicle that only makes 1% of mistakes a human would make. Would you trust this car? Probably. Let me now specify this 1% of mistakes of this thought experiment. These mistakes are accidents where the autonomous vehicle inexplicably crashes into oncoming traffic at 100 kilometers per hour. Would you still like to sit in this car? I think it's unlikely. So what is the point I'm trying to make here? For automated vehicles, the question is how to define safety such that the vehicle is considered safe by our standards. And how can the safety be guaranteed? And is it possible to reasonably describe safety with numbers? I said before, we will never be able to avoid all accidents. The goal here has to be to avoid self-inflicted accidents. We currently often simply consider how many kilometers test vehicles can run autonomously before a safety driver needs to step in, or we look at how many millions of kilometers are driven autonomously in simulations. However, these simple evaluations do not tell the whole story. Which types of accidents occur, for example? How severe were the accidents? Which scenarios were analyzed? And the very important questions were autonomous accidents maybe only avoided because other drivers were looking out for the mistakes of the autonomous vehicle. So what are we doing? What can we do to tackle safety? Automated driving is not developed by a single person, but it consists of multiple subtasks: sensing, perception, motion planning, which is the focus of my work, and so on. Obviously, sensing and perception need to provide a good understanding and picture of the environment. But I want to focus more on motion planning here. So which driving decisions does the car make? How does it execute these decisions, and so on? What's the goal for motion planning? It's simple: driving both efficiently and safely. But what are the challenges? The challenges are mostly uncertainties, especially in the prediction of the environment. So what is the intention of other vehicles? What are pedestrians going to do, etc.? So we need to plan our automated vehicle behavior given these uncertainties of the environment, while reducing conservative behavior and also guaranteeing safety. While there are a variety of different approaches for motion planning, I will cluster them into two groups. First, more traditional approach, there are control-based methods, which are based on reasonable rules defining what to do in which situation. And then second, there are learning-based methods. You've all heard of neural nets and machine learning. Those are the ones. Let me start with learning. With a lot of data, algorithms can be trained and then simulated, and there are impressive results. However, learning often includes black box behavior, meaning unexpected outcomes can occur and the reason is not always clear. So how is safety then addressed for learning-based methods? Usually with a lot of testing and simulations. But this can be challenging for official approval of automated vehicles. How many kilometers need to be driven to say the vehicle is safe? Do previous kilometers still count if the software is significantly updated? But also workers responsible for official approval need to always stay up to date with ongoing research and development for learning-based algorithms. The other part I mentioned was control. That is more my field, so I might be a little biased here, but basically one must design predefined vehicle behavior for each scenario, which can be quite tedious. But this then allows to guarantee comprehensively that each scenario is handled in a safe way. Unfortunately, I cannot tell you which of these two approaches, learning or control, will win in the end. But I advocate to use a combination of both, exploiting the individual strengths. And then there is one rather new development, mathematical safety verification methods, which ensure mathematically that a planned vehicle motion is actually guaranteed to be safe. These mathematical safety verification methods are already quite powerful, and they can be combined with either control or learning-based approaches. However, it is fundamental that there is a legislative framework determining the safety requirements that need to be taken into account. In order to bring automated vehicles out of the labs and to the public, we must focus not only on safely driving for millions of kilometers, but we must work on also verifying the safety. This is not only important to get the vehicles onto the road, but also to convince the public that these automated vehicles are indeed safe. As mentioned, safety requires an elaborate legislative framework. I hope that this talk can spark some exciting discussions towards this challenge. Thank you for listening, and I hope you enjoy the remaining webinar.
Excellent. Special thanks to Tim for the recording and making available his insight to us here today. Tim was the last of our speakers, and we are now moving into the Q&A session. I've received a variety of questions during the webinar and would address them now sort of topic by topic, maybe starting with Valerie and Anna on the drones issue. The first question, Valerie, goes to you. A member of the audience wanted to know, where do you see the main commercial use cases for drones coming towards us in the near future?
I would like to say that I see it coming in the passenger domain, meaning that passengers will be carried and transported. However, I think this is really something that we will not see before 2030. So the most likely use cases will be around, I don't know, transport of goods. Maybe that's already a high risk profile. But as I said, the transport of blood in the domain of medicine. Infrastructure surveillance is something that is already coming forward, and those, well, film photography are already realistic cases. So that's I think commercial use cases that are quite frequent.
Yeah, there was a similar question in that regard. When will we see Amazon dropping our purchases off the sky?
You tell me, maybe. I believe it will take some time. We do not have the ecosystem yet. We do not have the right infrastructure yet that we need for takeoffs, landings, for example. So those are all open questions that need answers before we have use cases that we see on a regular basis. What we already do is approving test flights. So that's something that is already out there, but seeing this on a commercial basis, it will take, I believe, years.
Okay, Anna, next question goes to you. What are your practical suggestions on how to react to drones on your property if you want to get rid of them?
I got quite sidetracked when I researched my talk because I thought that was really interesting. So in Germany, the drone was shot down with a gun. I don't have a gun at home, but you know, if you have a gun and you're good at shooting, you might try this. But there's actually a device which you can turn on, and that confuses the drone. And that way you just shoot the drone somewhere else. And I think that's the safest, because then you don't have the problem of shooting the drone and then it falls down and then it might land on someone else's head or someone's car or something. So then you don't have the problem with damaging someone else's property or actually hurting someone. So I would recommend, I think I can find the name of this. I have this, yeah, it's called a Copter Interceptor MP200. So that would be my recommendation.
Excellent. That's a clear answer from a lawyer. That's really good. Thanks. So staying in the liability area, Stefan, we had someone from the audience wanting to know, did you in your practice already see big or small liability cases either in Austria or abroad? And did they go to court yet?
No, actually not. This is one of the fields where law is first and practice second. Normally it's the other way around. We have heard a lot about legal acts concerning liability of drivers, holders of autonomous vehicles. However, there have been surprisingly few cases, or maybe also from an Austrian perspective, not surprisingly, because we have a satisfactorily working scheme of liability which does not distinguish between fault liability, or which does not distinguish between faults of the driver, of the owner of the car, and the simple risk-based concept. And therefore, I think the system works quite well. As I mentioned during my presentation, the situation is somewhat different in other European countries. And in England, for example, there has been quite recently there has been a discussion about the non-fault liability, which in the end led to a new act which provided for the liability of the insurance company. So I think the cases are going to happen, but we can cope with the problems.
Thanks. That's a perfect intro for our next question to Harald. A member of the audience wanted to know, what are insurance companies doing to prevent the use of smartphone devices while driving?
This is an excellent question, because this is exactly our business case. So we offer, or insurance companies offer, apps to their customers which run in the background and monitor driving behavior. And if users behave accordingly, so not using their smartphone, respecting speed limits, etc., they are rewarded with insurance discounts. For example, DVK in Germany gives up to 30% of discount on motor TPL. Unica in Austria gives you up to 50% of your motor TPL. And in addition, you're rewarded points, which you can use and redeem with partners. So you get your free coffee at the gas station, etc.
But how is that measured?
So we use smartphone technology. So we use the sensors of the phone. We use the GPS. We use accelerometer, gyroscope, and magnetometer of the phone. Of course, everything with the permission of the customer. The result is that the customers can see within their app their driving behavior. They're seeing exactly whether they respect speed limits, whether they are cornering or braking or accelerating too harsh or accordingly, and they are rewarded a score. And our backend servers then analyze the data. We run it through different machine learning models, and we apply this accordingly for creating risk scores.
What is the adoption rate? How many people in the German-speaking countries use such a device?
So the device is the smartphone itself. We have about 350,000 users in the German-speaking area.
That's impressive. Thank you so much. Our next couple of questions go to Martin, Michael, and René. Maybe Martin first. Are there any studies, a participant of today wants to know, at Uber on the environmental impact of ride-sharing schemes?
I think there are several studies being made. I don't have them top of mind right now, but I think the one area I would like to point out coming to mind here is the Spark initiative that Uber has started a couple of months back. That's an initiative identifying the gaps in order to get mobility, taxi mobility, towards electricity. What infrastructure is needed? Where's the infrastructure needed? Fast chargers, slow chargers. How do you close the finance gap? So I think there are big efforts on Uber's side in Europe with that Spark initiative to make sure that we continue to increase sustainability of person transportation and also making it an extension to the public transport network, which at the end of the day in every city should be the core of transportation.
Got it. René, maybe one question to follow on this from your end. Somebody from the audience wants to know, will individual traffic increase, maybe triggered by electrified and automatic vehicles, or will public transport be the answer to increased traffic?
In my opinion, individual transport will increase. It is electricity that powers our cars, and of course it's autonomous vehicles that will increase our demand of moving from A to B, because it gets it's just getting more convenient to do so. And if money wouldn't be the problem, every one of us would take a taxi for the daily ways from A to B. We just do not so because it's the most expensive way. But this will be the option, and therefore we say it's not technology only that will change the mobility behavior or the mobility system. And we have to really think about how we use these new technology possibilities. Yeah, this is only my opinion. I'm interested in how other people see it. Towards a climate impact of ride sharing, together with some universities, we try to figure out what will be the impact, because of course it's depending on how we actually move. But if we have the modal split in the background, we came up to around 170 grams of CO2 emitted on a kilometer, or saved by a kilometer of a shared ride. And having in mind that in a small country like Austria, more than 2 million people are commuting to work every day, there is the rate of occupation is around 1.1, so almost one single person in a car, and the daily way is around 30 kilometers on average. So there are huge possibilities in ride sharing.
Thanks. That's good news for Martin, I guess. Michael, next, what are your predictions for mobility within the next 5 to 10 years, especially with regards to autonomous driving? Your input previously suggested that autonomous driving is decades away. What is your own gut feeling? When will it happen?
It's a very good question, and I can tell you, when I started here at the ministry back in 2016, we all thought, yeah, this might be 5 to 10 years away. And now I'm representing Austria in a lot of European government groups and so on. And I can tell you that even car manufacturers, especially German ones, are telling us right now they are not quite sure if we will ever reach autonomous driving like it is defined by the car is able and capable of dealing with every kind of situation. Doesn't matter if we are inside of Vienna or in the mountains. And so what I think, we should not talk about this kind of autonomous driving where the car is capable of dealing with every kind of situation. But what we see, especially in Europe, is that we have to talk about automated and connected mobility, where the car is in a cooperation and a connection with the infrastructure, with other cars, because it's the only way to enable the successful and sustainable implementation in terms of climate impact, in terms of reduction of road fatalities. So I would say we will see within the next years, of course, specific kind of so-called operational design domains. We will see highway pilots. We will see this kind of small shuttles driving around in restricted areas. Everywhere where there is a kind of low complexity. Quite sure that we will see them within the next years. But when we imagine a car waiting in front of the ministry and driving through Vienna till, I don't know, Germany, cross-border, I'm not quite sure if we will see this within the next 15 or 20 years. And why we see something like that in the States or in Asia, it's because they changed everything. They have made up roads for hundreds of billions of dollars just to make sure that their cars are able to drive there. And it's called autonomous. But the same vehicle would not work in Austria, would not work, I don't know, in Denmark or wherever. It's just a kind of operational design domain. So I'm not quite sure if we will ever see this kind of autonomous driving, but I'm quite sure a few aspects of automated and connected driving we will see very soon within the next years.
Thank you. And conscious of time, last question, maybe of a philosophical nature to Nicola. One of the audience wants to know, will you ever see a landing on Mars in your lifetime, a manned landing, that is?
Well, I like philosophical questions for sure. Yes, for sure. I mean, there are two variables, I guess, how quick we are on the planet and how long I will live. I think one is decreasing or increasing. The other one is, I will live pretty long, I guess. On another note, of course, we're pushing the boundary for space exploration. NASA has set out SpaceX has set out the clear goal to put a man on Mars. Or woman. In this case, yes. Straight answer, yes. But of course, there are multiple hurdles to take until then. And I think, as pointed also in my brief presentation, first of all, we need to really know the place, because the Martian environment is really harsh, and we need to know where is water, where are resources we can utilize on the planet. And there is much more to learn from robotic exploration at this point before actually being able to not only send a person to Mars, but also sustain life, which I guess is, from a humanistic perspective, also the right thing to do. I think we could send a person to Mars already, but not quite sure how that would unfold.
Got it. Thanks for that. We'll stay tuned for sure. So at the end of our today's event, a big thank you to our hosts, our speakers, and all the participants for sharing your know-how and contributing to the Wolf Theiss, the future of Sirius. If you're hungry for more insight into what the future might look like, stay tuned and register for our next event on the future of government, taking place on the 25th of November. Until then, have a great day and see you next time. Goodbye.